Okay, so today we will learn about how to solve the quadratic equation using the perfect square method or completing the square. So quadratic equation with the form of y equal or 0 equals ax squared plus bx plus c, and we want to solve the quadratic equation using the complete square or by completing the square, complete square or perfect square. It's up to you. Okay, so before we learn about the complete square, I will give you the basics of the complete square. So what you need to know in order to follow this quadratic equation solution with complete square is the spatial identity. Okay, so the spatial identity of quadratic equation. So what is the spatial identity? The spatial identity is y. Wait. Oh, okay. The spatial identity is, for example, a plus b square is equals to a square plus b square plus 2ab. So you can put 2ab in the middle of the equation or on the last side. You can write like this also, a square plus 2ab plus b square. So I don't want to focus on how do you expand a plus b because we learned it previously in the expansion method. Or a minus b. So if I have a minus b bracket square, so it's supposed to be a square plus b square minus 2ab. So what makes the difference? The difference is only on 2ab. So on plus, everything is plus, including plus 2ab. If I have the difference of square or the difference of a plus b square, a minus b square, so the negative will be on the 2ab. Or you can just write like this, a square minus 2ab plus b square, right? So either on top side or bottom side, you can choose both. Yeah, you can choose either or, sorry. So this will be our basics on calculating the spatial identity, complete square, I'm sorry. So this is the complete square, right? So complete square means something square like this. Okay, so this is the main idea that you need to know. And if I have a plus b, a square plus b, I just give the x, I just put in the proper calculation of algebra. So let's say if I have x squared plus 4x, and I want to make this into a complete square. How do I do this? So I want to give you the approach of what I say, the graphical approach or the drawing approach. So I have x squared. So I have a square that has a side of x, right? And I have 4x, right? So plus 4x. So we have, for example, this is the same length of the x. So this is x also, or rectangular method, yeah. Rectangular to a square model. So this is the easiest part to understand the basic of complete square. Okay, so I have 4, for example, here. So x squared plus 4x. So how do I do the rectangle part? For example, here, this is x if I combine, and this is 4, right? So this is 4. This is still a rectangle form, right? So when I want to put this rectangular form to a square model, so what I can do is just simply divide this 4 by equal side for each. So I just draw the thin line with a green color. And I want to pick this and I want to put here, right? So it will be creating an almost square shape, right? So again, I don't change the x and x here, the x square, right? So this is x square. And the 4, you divide by 2, right? So you cut into half. So this will be 2. And still, this is x, right? We don't change the value of the width of it. And also here, I just put on the bottom of the square. So this is x also here. This is almost square, right? But we have this leg. So this is nothing. So we can change this form, the x squared plus 4x, become x plus 2 bracket square, right? So x plus 2 bracket square. But memorize, or not memorize, you have to acknowledge that this is a leg. A leg means an empty space. You have to subtract with 2 times 2, right? So the length is 2, the width is 2 also, or it's another smaller square that you have to subtract in order to follow the idea of perfect square. Okay, so 2 square, right? So this is the basic, and let's do the general form, right? So you have to subtract with something that is empty, that is not here. This is non-existent. Subtract them, okay? So the main idea or the general form of a quadratic equation with a complete square, or the conversion of regular x squared plus bx. So we focus on this. You can just write x plus, right, b over 2, right, because it is 4 become 2. So it is b over 2 square, right? So this square, and then subtract with the 2. What is 2 actually? 2 is the half of 4. B over 2 bracket square. So this will be the simple formula for quadratic equation. Oh, sorry, for the conversion of a simple expression of quadratic to a complete square form. What means by complete square? Again, I want to remind, this will be the complete square form, right? So, or perfect square, up to you. Depend on your teacher teach you what definitions. Okay, so this is the basic. So I will give you another model. I want to save this first. A quadratic equation 1. Later on, I will show. I will give you the files, the JPEG. Wait, and another model for complete square form. So to make it simple, a complete square, wait, it's too thick. A complete square can be written like this. Complete square method, or perfecting the square. So again, I want to draw a square with x squared plus bx. So bx means b times x, right? So I better use the other color, bx. So where's the c later on? We have to ignore this at first, okay? So let's say bx is like this. I just make it thick. I just make it this, okay? So what you can do now is try to solve this, or to think of how do I make this rectangle into a square, right? So this is not a square, this is a square and rectangle, and you combine this, you will get a rectangle. This is the rectangle, right? So it's not same in width and length. So I cut this in half. So I cut this in half, and I move the right side, or anywhere actually, on the bottom, right? So I just redraw it one more time. So this will be the purple one, the x square, right? And then you cut the blue part by half. So this is b over 2, and then this is b over 2 again, right? I just move the part. So this will be x squared, and then this will be half b, and this is half b also, and this is x, and this will be x, right? And then we have one empty spaces here. I just use the red color. So this is non-axis. So it's supposed to be subtract with something. So what you can do is, what is the area of the huge square here? So x plus half b. Oh, it's so bad to see. Wait, I want to use the other color maybe. Yeah, there you go. X plus half b, and then put the square, and then you have to subtract with the non-axis part. So what is the non-axis part? Half b bracket square, or b over 2 bracket square. Or you can just write like this. I think this will be easier to see, not half b, but b over 2. So it's more simple, right? That's all. So this will be our pattern of perfecting the square. The next question is, how about if it is minus? If it is subtract x squared minus bx, how do you do that? It's the same, right? So when I can change x squared plus bx become this in a perfect square form or complete square form, the negative will also follows, right? So if I have x minus bx, x squared minus bx, you can just change the positive to the negative. So x minus b over x, b over 2, sorry, b over 2 bracket square. And okay, I did something wrong here. This is not plus, this is minus. Okay, this is minus. And subtract with, again, the subtract is unchanged. Why? Because as we focus on the first knowledge, so this will be x squared minus bx plus b squared over 4, right? So it's always plus, so you have to subtract. Still, it is subtraction. B over 2 bracket square. Right? So it's the same, but what is changed? What is the difference here? This will be the difference, right? So on the right side will be negative. Still negative. Why? Because it's square, right? So don't, it's no matter whether it is negative or positive. That's all for the explanation of complete square method. The exercise will be given after this. Wait, there you go. Quadratic equation 2, and there you go. Okay, just save it. Later on, I will show everything. So let's do the exercise. The example. I don't want to give you exercise yet because we are focusing on the example. So how do you do the example? So example. Solve with quadratic equation. Oh, sorry, the complete square method. Complete square method. Okay. So I have x squared minus 5x, or 4x better to make it simple for the first part, plus 5. See, there is one equation or one variables that, or one terms that is not exist from our first, or from my first explanation, this. But again, don't focus on the plus 5. So you have to focus on this one first. So as the following formula, x squared minus bx or plus minus bx, you can just change like this. Again, the general form will be x plus minus b over 2 bracket square, right? This is the complete square, and subtract with b over 2 bracket square, right? So just write like this. And if this is negative or minus, subtract by 4x. So what you need to do, 4 divided by 2. That's all, 4 divided by 2. So I think better we draw it, we write it downwards on the bottom. Minus 4 divided by 2. What is 4 divided by 2? 2. And put the bracket close and square, right? And then subtract with 2 square, right? B over 2. So this will be. So I think when we try to follow the formula on the questions, it's getting simple and more understandable, rather than you just write b because it's in terms of variables and so on. Okay, so 2 square, and then we try to continue the equation plus 5 later on, right? Oh, I forgot to put 0 here because we have to solve it. When we are solving this, we have to find the answer of x, right? So you just continue. So it's the continuation of the plus 5. So the plus 5 is nothing doesn't change any value or any rules of the quadratic or of the complete square formula. Okay, so we try to finish this question then. How do you solve this? Okay, later on, we try to continue. And then what is 2 squared? 2 squared is 4, and plus 5 equals to 0. And then x minus 2 bracket square plus 1 equals to 0, right? Just continue the equations. And then x minus 2 bracket square equals, you put 1 to the right side, becomes negative 1. And what you can do now, it's getting simple. Square root both sides, right? So we see that the question is impossible to solve. Why? Because we have the negative value of the root. The root of negative value is non-exist. So x minus 2 equals to square root of minus 1. So x equals non-exist or no answer at all in your grade. So actually there is an answer about the imaginary number, but we don't focus this yet. But we know that how to do this with the complete square. So the blue part is the complete square method, right? So I think this is the hard question. Let's do it in a simple question. So second example, let's find the equation that has solutions. Okay, so I will give you some questions. X squared that has a solution, minus 8, for example, and then plus 2x. I think we have the answer here, equals to 0. Okay, so how do you solve this with a complete square formula? First thing, focus on what we are doing here, right? So focus on x squared plus minus bx. Again, so first thing, put the bracket and put the square. That's the complete square model or complete square pattern. And then you put x plus, right? This is plus, so 2 divided by 2, 1, right? And then subtract by 1 square, right? So I just want to annihilate the arrows so it's more simple to see. And then subtract by 8, right? Just continue the equation, equals to 0. So x plus 1 bracket square minus 1 minus 8 equals to 0. So x plus 1 bracket square minus 9 or equals to 9. As simple as that. And then what you can do now is square root both sides. How do you square root both sides? As simple as this. Square root, so annihilate the square. So x plus 1, that's all. And then 9, if you square root of negative 9, what is the square root of negative 9? It's supposed to be either 3 or negative 3. So you have to put both. You cannot put one, not just like this. Okay. It can be plus minus 3. So you can find the value of x is plus minus 3, and then 1 is going right, becomes negative 1 or minus 1. So we have two values of x. First x will be 3 minus 1, right? You find you use the or take the positive 1, 2, or x2 will be, take the negative 1, negative 3, negative 3, negative 3 and minus 1. So minus 3, negative 3 minus 1, negative 4. So we have two values of x. So this is the solution of the value, right, of the equation in complete square method. Okay, so I will save this. Now, we are done for the explanation, and I want to stop the recording right now. So now when we want to find the quadratic value or the values of this quadratic equation using the perfect square, so what you can do now is to divide all the equation by 2. Why? Because you have to annihilate this. Why?
Yeah.
You
Yeah.
are
Yeah.
having this, right?
Yeah.
So the rules is x squared plus bx. Right? So we don't have any number here. This is 1. So you divide by 2. After you divide by 2, so you can do the rest. Okay, so this is x squared plus half x minus 15 over 2 is equals to 0. And now you may do the complete square method. Again, draw the bracket and then subtract with this, right? So focus on the first two terms. So this is x and plus. There you go. So this will be the harder part. Half divided by 2. So what is half divided by 2? So it is half times half, right? So you divide half by 2, becomes half times half. So 1/4, right? So that's the answer, 1/4. And then 1/4 square. And continue minus 15/2. Right? We'll continue the third terms. And then equals to 0, third term. Equals to 0. What next? So let it be, this will be the fractional operation. So 1/4 square. So 1/4 times 1/4 is equals to 1/16. I do something on the right side so you can imagine what is 1/6, where is 1/16 comes from, right? So and then minus 15/2. And another problem is exists. What is another problem? Another problem is you cannot subtract the numbers that has the different denominator. So what you have to do is try to combine the denominator or make the denominator equal by multiplying the 2 by 8, right?
Yeah, 8.
That's right. So 16 and 16. So let it be x plus 1 by 4 bracket square, subtract 1/16, subtract, okay, that's a huge number, 120/16 equals to 0. And what next we can do, as usual, minus 1 minus 120. So minus 121/16. So it's the same, but the harder question is about, the harder understanding is about the fraction. And next we can do x plus 1/4 square equals to 121/16. Since 121 and 16 are a square number, so it's simply just, it can be simply square rooted out. So square root both sides. Okay, we don't have space, so do on the right side here. So you just annihilate the square on the left side, and the bracket also, to make it simple, equals plus minus square root of 1 to 1 is 11, right? Square root of 16 is 4. We get the answer. And then x equals plus minus 11/4. You just put the plus 1/4 to the right side, become -1 or minus 1/4, right? What you can do now is x1 and x2. So which is, what makes the difference? The difference is on, first step, you have to divide to achieve or to get x squared, right? And second, you have to focus on fractional operation. That's the hard part. So I will give you this. And then next, first take the positive one. So the answer will be 10/4, right? 5/2. Or you can just change to a mixed fraction to 1/2. Okay. Either or, both of them are right. And second one, we'll take the -11/4 and minus 1/4. So -11 minus 1 is -12/4, right? So what is -12/4 is -3. So that's the answer. Okay, so this is the further quadratic equation solving with a complete square method. Okay,